This video is to check the ferroresonance of the Tesla coil, and the input is as usual, and then the Tesla coil has 130 turn, which is this one, and then it's radiated through the antenna there. And what I'm measuring is actually I put the copper bar, and then I am measuring the 90-degree electric field or voltage. This is what I'm measuring. And I put the 1 kilo ohm resistor and then blue. It's not blue. Okay, it's a red probe is voltage, and yellow probe is just seeing the radiation. Just seeing the radiation in the air like that. And then so it's interesting. It's not when the radiation is strong, the ferroresonance is strong. It's different. First, I start with 100 kilohertz. 100 kilohertz, and the interesting thing is the high frequency. Low frequency, I don't know low frequency. It's 100. It's 100, and then the high frequency is appearing. It's about 1.3 megahertz, and this frequency doesn't change. So actually, I think this one is optimized for 1.3 megahertz. Although I thought it's 1.6 or 7, so whatever. So it's 1.3 megahertz it's surviving always, although I put the low frequency. And then although I changed the frequency like that, it's a 500 kilohertz. Now I give the input. Again, the frequency that is surviving here is a radiated term. It's about this time is 1.6. It's around this area. Okay, and then I will continue, and I'm going up the frequency now, like that. And this looks like a ferroresonance. Around here is a 500. The yellow is radiation, and then red is a ferroresonance, which is the copper bar voltage. I'm going up the frequency now. It's 730. So it's always the ferroresonance appears from time to time. Now the radiation and ferroresonance both are quiet at 800 kilohertz. And then I'm going up. Yeah, this is interesting point. First interesting point. The radiation is weak, but the ferroresonance is strong. And the input is about 1 megahertz, 975 kilohertz. So this is a proof that it's not always the radiation is interfered into the copper bar. So radiation is weak now, and then I'm going up the frequency more. Now it's 1.2 megahertz, and then yeah, this is another ferroresonance. It's a 1.3 megahertz. The radiation is is kind of strong, but the ferroresonance is really strong. And what is funny is at this time, the input current is half an ampere. It's really not consuming much. And the high frequency that is interfering always is about 4.05 megahertz. I don't know why it appears. And then I'm going up the frequency still. Now this is the point that I thought it's always the optimized point, which is the highest radiation, and then the ferroresonance is also strong with a good form, and the frequency is 1.6, nearly 1.6. The input is 1 ampere, and this one, I thought this one is gonna be the right point, but there are interesting points still, and I'm going up the frequency again. Yeah, when it's really shaky like that, then what I can see is this low frequency this low frequency interference because of the it's shaky. It's not the digital sampling noise. I've checked with the analog oscilloscope. It still appears there. So it means it's picking up the some ambient energy which has the low frequency. So that's the 1.7 megahertz area. It often appears. Now I'm going up the frequency, and then another interesting point is coming now. Yeah, so ferroresonance is increased here again around here. It's 2.3 megahertz, and the input current is nearly 1 ampere. So this is interesting point. It's because the radiation is nearly negligible, but the copper bar picks up lots of wave from the Tesla coil, which is a proof of the ferroresonance or nuclear magnetic resonance. Now it's going up, and then there is another interesting point appearing. It's 2.7 megahertz, looks like another ferroresonance, and then this one has again something like a fishbone, and then I'm going up again because the interesting point is still about to come. Yeah. Yeah. This one. Radiation is nearly zero. Not zero, but it's really, really small compared to other radiation. It's 10 times smaller. But the ferroresonance is really great. The input current is not much higher, a little bit higher, at 3.385 kilohertz, 3.4 megahertz, and then I'm going up. Then this effect disappears, and then now ferroresonance is small, radiation is small, and nothing special. Maybe ferroresonance is still okay. So now I'm going up higher, 4.4, and then 5. So higher than this, I don't think my Tesla coil can cope. So that's it.